Hi everyone, I am Arjyahi and me and my teammate Charith are going to present our project on enhancing zero-shot learning by combining clip embeddings with knowledge graphs and graph neural networks. Imagine teaching a child what a zebra is. You don't need to show them thousands of zebra pictures. You might just say it's a horse but with stripes. And they will get it because they understand relationship between concepts. But machine learning models usually need tons of examples to recognize something new, and that's not scalable. We can't possibly label every new animal or car or object that appears in the world. And that's where zero shot learning comes in, which is the idea that a model can recognize things it has never seen before. But most existing models like CLIP mainly rely on text descriptions. They don't really understand the relationship between things, like how a zebra is close to a horse. And without that understanding, their predictions can be shallow and sometimes just wrong. Today, most zero shot systems focus on matching text to images, but they miss out on relational knowledge like family trees between species or visual similarities between objects. And without that structure, the models are brittle. If the text isn't perfect or the task is very fine grained, the model can struggle badly. So, our goal was to push beyond that by not just teaching models about individual words, but teaching them about relationship between classes too. We have used the animals with attributes 2 dataset for our project, where we have used 350 images per scene class for training and 20 images per unseen class for testing. Now, Charith will walk you through the approach and the results.
Thank you, Arjyahi. If you could look at the methodology, we have three pipelines, which I will be explaining briefly. So in our approach, we built an efficient bridge between what the model knows and what it needs to guess. First, we built a knowledge graph, a simple map connecting classes. For example, like showing the how the zebra are like white horses with black stripes, which you can see on the right side of the poster. Then we used clip model to create text embeddings, basically 512 dimensional vector for each class name. Next, we refined these embeddings using relational graph convolutional network or RGCN. You can think of it like letting each class talk to its neighbors and then adjusting its position based on who it's connected to. We've added something called prototype refinement loss, which makes sure that classes stay close together and unrelated class move further apart. This is the RGCN training pipeline. After that, we've trained a MLP model, a simple neural network that learned to map scene class images into this new improved prototype space. This is the multi-layer perceptron training pipeline. At test time, the model, which has never seen an image of, let's say, a zebra, could recognize it by finding the closest refined prototype space, like matching a new image to white horse with stripes. This way, the model wasn't just memorizing labels, it was reasoning based on relationships. So this is the inference pipeline. The results on test dataset was pretty good. Our system achieved perfect adjusted accuracy, meaning if either the top correct guess or the very close guess was correct, it got it right every single time. Even though the strict top one accuracy, where only the first correct guess counts, was around 59%, when we allowed related guesses, it made our system perfect. Here's what we learned. Relationships between concepts really matter for zero shot learning. Structured knowledge and better embedding spaces help models think more like humans. In the end, our work shows that to truly make AI smarter, it's not just about more data, it's about teaching models to understand meaning, structure, and relationship just like humans. Thank you.